This is BSA by Design, a podcast about transforming healthcare, educational, and research facilities through expert design and insight. I'm your host once again, Brian Moore. My guest in this episode is Brian Hoagland, a principal and senior electrical engineer at BSA. We're going to discuss the critical role of engineering and project planning. Brian is a graduate of Purdue University, where he received his bachelor's and master's degrees. He has been with BSA for 25 years and has worked on and led several impactful projects, including Dudley Hall and Lambertus Hall at Purdue, the Neurodiagnostic Institute and Advanced Treatment Center, the Indiana Biosciences Research Institute, that's IBRI, Advanced Research and Innovation Facility, Research 1 and 2 at the University of Notre Dame, and Eskenazi Hospital.
By the way,
Welcome to the show, Brian.
Yeah, thanks for having me.
This being the first time that you've been on the show, could you tell me a little bit about your journey to becoming a principal at BSA, how long you've been with BSA, and really, I guess, go all the way back to, what sparked your interest in electrical engineering?
Sure. Yeah, well, I guess after 25 years, it is appropriate to call it a journey. It's hard to believe I've been out of college for that long. But in some respects, I came to BSA straight out of college. It's been the only place I've worked. So technically, I haven't traveled very far in my journey, but I've been a part of a lot of change and a lot of growth during my time at BSA. So it's very exciting to look back and see what we've become. As far as my road to becoming a principal, I've had the opportunity to wear a lot of hats over the years, experiencing different parts of the business. Initially starting out as an electrical designer and working towards getting my PE license and kind of being responsible for my own work. That was kind of the first milestone that I got to. And then, shortly after that, I kind of transitioned into a leadership role within the electrical department, overseeing staffing, hiring, those types of things, and did that for a few years, and that kind of morphed into being the director of engineering when that spot opened up. So transitioned from looking at just the electrical piece to engineering as a whole.
Sure.
So those transitions was very, very project based early on in my career, and then going into the director spots, it was more managing people.
Yeah, a lot more strategic. Yeah.
Sure.
Mm-hmm.
So being able to experience different things, I think, was helpful. And then after a handful of years of doing that, I was really ready to be done doing that.
Yeah.
And I kind of went back to where my passion lies, and that's really working with great clients,
right,
working on great projects. So the principal role seemed like a great evolution of where my career's wanted to go. Now, I guess to your earlier question about what sparked my interest in electrical engineering specifically, thinking back before college, I was always interested in physics and math and calculus.
Yeah.
The important subjects in life, right?
Right.
Ultimately, I always liked to solve a problem or see how things work and make them work. So exploring something STEM related was just a natural evolution for me. And then growing up in a small town an hour away from Purdue, my college search was really abbreviated. I always knew where I was wanting to go. So it made things.
Where did you grow up?
Just out in the middle of nowhere, western part of Indiana.
Okay.
So,
same, little south of Indianapolis, but rural community. Yeah.
So
kind of predetermined where you were headed.
For sure. Well, yeah. I mean, you grew up in a little community, and it's like, I guess I'm just going to go to Purdue, right? Which, in hindsight, what a great place to be.
Right.
And then, electrically specifically, I just picked something, and I guess I picked right.
Yeah. Interesting. Well, I think given that background that you've provided us, I think it's perfect to have this conversation about having some foresight with engineering, keeping engineering part of the planning process. I guess I want to start out with, at what stage should engineering considerations enter the planning process, and why?
Yeah. Well, probably not a very great answer, but it depends.
Right.
It's going to be somewhat project dependent, but from an engineer's perspective, earlier is generally better. And specifically in the types of markets that we work in and the complex nature of those. Having that engineering voice at the table, I think, is very important. And that may be somewhat formed or biased from working in an AE firm that is so focused on a full service mindset, where having that engineering voice at the table early we feel that that's important.
It's just the considerations, right, of like all the stuff that you guys are providing that the architects may not be thinking of, correct?
Sure.
Same as in interior design even, right? Like
in the planning piece of it, we're not getting, I guess, into
the weeds.
We're really trying to focus on, the big picture systems in the building.
Oh, yeah.
Things that impact square footage, potentially building positioning, and then largely things that drive cost or schedule. I mean, we're really trying to nail down in a big way, in a big picture mindset. What's the engineering scope? And let's nail that down before we move into the design phases of our project.
So what are some of the risks when engineering expertise is brought in too late then on a project?
A few things come to mind. One of those is the risk to spatial planning and how the building's
equipment, right?
Yeah, being able to we want to be able to provide early input and to be able to right size those MEP spaces and then get them sized right, but also putting them in the building in the right spots.
Right.
That's going to affect the overall program of the building. But we're trying to look at it from how do we facilitate and provide a flexible and cost-effective way to serve the building. I mean, it's way easier to move things to planning
than it is
later on,
right? When it's physically there.
And then, other risks, cost obviously is important to every project. Generally, owners are going to want to know what's roughly my cost going to be as we leave the planning piece. And if MEP is not there to define those systems, I think there's vulnerability to have cost plus at that stage. And then lastly, just making sure we have conversations with the stakeholders early in the process, asking them about, do you have energy goals?
Yeah.
Do you have, what type of resiliency do you want? How maintainability, what's your thought process on that? As an example, finding out that in the design phase that an owner has an aggressive energy target, and we didn't identify that early, that's going to have likely going to have a cost or spatial impact.
Right.
And we're going to end up backtracking.
Yeah. And it's going to take longer, cost impacts, right? Okay. So walk me through your process for identifying potential engineering challenges during this planning phase. You've mentioned a few, I think, already, but.
Sure. And I don't think it's really that different from the overall planning process of the architects. First and foremost, everyone, the goals of the project and the values need to be clearly defined. These get given fancy names, banners or pillars or tents, whatever we call them. But if nothing else, we will achieve these
things. Yep.
And as an example, on the two past Purdue projects, those project goals and values were established, and they were shared at every design meeting.
Yeah.
To the point where it was like, are we talking about this again? But no,
keeps it at the forefront, right?
Correct. That's the why for what we're doing. And then beyond, after those are established, we again want to have alignment sessions with the various stakeholders. We want to talk to the building owner. We want to talk to the researchers, the user groups, and then obviously the engineering or facility groups for the university. We want to have those discussions. And how would you define a successful project?
Do you get varying answers from time to time? Of course.
Sure, absolutely.
So who trumps?
That depends too.
That's a follow-up conversation, right?
Yeah.
Hey, we've identified these things. They're not in concert with each other. So how do we get through that?
Okay. Yeah, and that's, the next step was just gaining consensus on what we just heard.
There you go.
Where the engineering group may say, hey, sustainability or this energy target is most important to me. As a team, we're going to agree upon here's where we're going.
Right.
And we're going to use those to define our overarching engineering solutions for the project.
Okay. So you just mentioned you've worked on some projects at Purdue. You've also worked on several at Notre Dame. What unique challenges do academic institutions present from an engineering perspective?
Sure. And I guess I'm going to start off by saying that Purdue and Notre Dame are obviously world-class institutions.
Oh, yeah.
And it's a privilege to work at both. Purdue being my alma mater is pretty cool.
Right.
And then, Notre Dame, it's a special place. It's some amazing people. So what a blessing it is to work on those. From a challenges, things that come to mind, I don't know if they're challenges, we'll call them opportunities, but we're designing buildings that are going to be there for 50 years or longer, right?
Yeah.
So we need to design systems a little bit differently than we might somewhere else. Designing spaces that are flexible for a variety of uses, spaces that are easily adaptable to the next researcher.
Right.
Designing systems that can be maintained.
Yeah.
Again, they're going to be there for a long time. We don't want to design something 10 years from now that the owner's going to be like, why did we do that?
Right.
But some other things, client standards at times can be restrictive, maybe limit a little bit of creativity.
Yeah.
Obviously, those are there for a reason. They want to maintain consistency for what happens on their campus.
Right.
But I think it's important as part of our process is that we evaluate those, we talk about those, and sometimes we challenge those. Is we understand that that's what this says, but is there an opportunity to do something a little different that might have some benefit?
Yeah.
So things that I think are important to do in that early stage. And then lastly, just a lot of buildings on university campuses are going to get delivered campus utilities. They're going to have a tunnel that come to them that brings steam. They're going to have chilled water that come to them. So that, again, is going to potentially limit a little bit of creativity on what systems we may propose. Something on a greenfield site might be a little bit different. But I guess I'll close on that question that both Purdue and Notre Dame are both very forward-thinking clients, and they're always willing to listen. So, it's why I really enjoy working there. They're open to evaluate new methods.
That's very cool. So can you share a specific example from one of these projects that you've worked on where early engineering planning prevented maybe a significant issue from occurring down the line?
Yeah, it's difficult to say that it would have been a significant issue, but
especially when you prevented it, right? Right.
But what comes to mind are highly specific or environmentally demanding research environments. Not understanding those could lead to significant challenges. Examples could be like an intense computational lab with a large power need, or specialized environments like a BSL-3 lab or a vivarium. It's important for the engineering team to have the opportunity to express our opinion on the ideal placement of these types of spaces in the building and where the mechanical or electrical rooms are going to be located to serve those, and then come to consensus with the architectural group on where's the best place for this to live in the building.
Are there certain spots based on, if it's facing north, south, east, west, sunlight, heat, cold, where you're putting equipment in the building? Is it more centrally located? Does it need to be against the east wall? Or is that some of the stuff that you guys are?
Well, sure. I think, electrical engineer talking about mechanical stuff. So please forgive me. Positioning of the building, that's something that is talked about now.
Yeah.
How do we orient this building from a solar standpoint? Right. Where's the glass going to be located? Those are things that get modeled today.
Yeah.
10, 15 years ago, those things really weren't talked about a whole lot.
Right. Okay. Interesting. The Indiana Biosciences Research Institute project probably had some specialized requirements, I'm assuming. What engineering considerations are critical for some of those research facilities like you were talking about?
Sure, yeah. The IBRI project, it was a fun project. I enjoyed working on it. It was exciting to watch the early phases down on the 16 Tech area downtown.
Right.
And then, like most projects of this type, there were some challenges. First one that comes to mind is that it was developer-led. Not a challenge, just considerations.
Just different.
Yeah, different. Yeah, you approach that type of building differently than you might approach a university-owned building.
Right.
And then it was a multiple tenant lease space. So you might have one group that takes over part of the first and, multiple different tenants throughout the buildings.
Yeah.
Understanding that and how are we going to arrange the engineering systems to accommodate that, to create flexible environments, to create adaptable environments? It's kind of a puzzle you kind of have to put together.
And you don't have all the pieces sometimes.
Well, early on, you're trying to put it all together, right?
Sure.
Sometimes you're playing with, sometimes those pieces aren't there yet.
Yeah.
Yeah. Kind of to that point, as an example, we oftentimes design spaces for researchers that haven't been assigned or identified.
Right.
So
you don't know who's taking the space.
yeah, and a lot of times maybe we think we do, and prior to moving in, it's somebody different.
Mm-hmm.
So, I mean, if you're designing solely for the purpose of that one lab, you've missed the mark.
Right. How do you collaborate with scientists and researchers to understand their technical needs as a follow-up to what you were just talking about? I mean, sometimes you don't know them. In the cases where you do, what kind of questions are you asking them?
Sure. And I mean, I think I mentioned it earlier, but we, as an engineering group, we really want to have those conversations with the various stakeholders, the scientists and researchers being one of those. I always enjoy starting off the conversation and tell me what you do.
Yeah.
You quickly learn that you're not the smartest.
Right.
You know, stuff's flying over your head. But
that's how I feel when I host this podcast. Yeah.
So that process is going to involve us collaborating with our lab planning teammates,
right.
You know, creating questionnaires, creating room data sheets that are going to identify specific MEP needs that are important to help us identify the engineering criteria for the project. And then a lot of times what is very beneficial is if it's possible to walk through their existing space. We can gain a lot from having them walk through their space. This is great. This stuff doesn't work. It helps us see and helps them be able to talk through what they're doing.
Right. That makes a lot of sense. So how do you effectively communicate complex engineering concepts to non-technical stakeholders?
Yeah.
This is a big question for me because I'm in the non-technical group. So it's like, how do you go through and explain some of this stuff?
Sure. And my experience, occasionally this is an issue.
Yeah.
More times than not, the stakeholders that you're dealing with have a pretty good grasp.
Mm-hmm.
So, I mean, it's usually not an issue, but when it does happen, I guess relating them back to past project examples or other buildings that they are familiar with.
Oh, yeah.
Can help explain the intent. I know on research too at Notre Dame, we would often refer back to, hey, this such and such lab in McCourtney 1 or this mechanical space over there in McCourtney. That allows them to get some firsthand knowledge of something that they've seen before.
Now you get them on a common ground,
Sure.
right? And they're understanding better.
And I guess lastly, it's generally true that a picture is worth 1,000 words. So
yeah.
If we can communicate with a graphic or a chart or a rendering, and I think that it definitely applies architecturally as well.
Yeah.
It's way easier to convey our message than trying to talk through it or write it.
Usually works so well. You're right. It's what's the old joke? Like, explain it to me like I'm 5. When picture's going to work really well in that case. What strategies have you found effective when collaborating with architects, construction managers, and clients during planning?
First off, I think just connecting with the stakeholders, the design team and the construction team, that can go a long way.
Right.
And in my book, a Zoom or a Teams call doesn't meet that criteria.
You want to be face to face, same location. Yeah.
I think it's important to gain that trust right up front. And certain projects through the years kind of stick in my memory for different reasons. And an example of that I'll mention is a new cancer center we did a handful of years ago. We members of the hospital, the design team, the construction team, we all gathered for the kickoff meeting. And the first thing they did, they brought up a video, and it was of patients telling their story of why this building is important to us.
Mm-hmm.
And I mean, after we all kind of wiped our eyes from hearing all the stories.
Yeah, very powerful.
Yeah, I mean, it's just a great way to establish trust and really understand the why behind why we're doing this project. And then just simple things beyond that, active listening. I mean, listen more than you speak. A lot of times we're not going to be the driver driving lots of the conversations, but it's amazing what you can gather by just listening.
Yep.
And then ultimately just being a good teammate. Open the communication paths, be receptive to other viewpoints, celebrate others' victories. Just simple ways, but effective to lead to success.
Yeah, it keeps the team across all those different areas tight-knit. Yeah.
Sure.
Interesting. Okay, I want to talk about what are some of the most common engineering oversights you've seen in project planning, or some of those overlooked things?
I mean, the obvious one is the spatial planning piece of it, allocating enough space and having it positioned in the building and what we feel is the proper location.
Mm-hmm.
If engineering isn't involved in planning, I mean, this is often something we have to deal with in schematic design.
Yeah.
And again, it's way easier to do it up front And it helps from a costing standpoint to do that early on.
Because if you're doing an SDs, I'm assuming it's slowing it down.
Yeah.
You got to go back and.
Sure.
Okay.
Yeah. I mean, it's costing us time and it's costing everybody time.
Right.
And we're having to backtrack and then try to catch back up. So it's trying to avoid that, working backwards. But just I think it's important to have those engineering related conversations and convey the full engineering scope as you exit the planning phase and head into the design phase. I think it's critical. Again, budgets are almost always established at that phase. And if there are major gaps in what we're going to be doing later on, something's going to get cut.
Right.
Client's not going to be happy generally. So
right.
Getting those on the table up front is important.
Okay. Well, if you've listened to the show before, I like to ask our guests about the future a little bit as we wrap up here. So how are emerging technologies changing how engineering integrates into project planning, or any future trends that you're monitoring?
Yeah. What comes to mind, something you hear about every other commercial, the main topic in every conference, AI.
Yep.
That's probably not surprised to hear.
No.
Guessing.
But I do want to hear your perspective, because we hear it a lot from different folks around the firm. And
I am cautiously interested. I don't know if that's.
I like that.
The way to say that.
We'll go with it.
Okay.
Yeah.
I mean, how are we going to leverage AI to enhance how we approach a project? I mean, what tools can we leverage to analyze solutions faster, analyze more of them? And then, how do we gain that instant feedback loop to make those decisions that are going to be impactful early on in the process? Honestly, it's a bit scary.
Yeah.
But it's something I think the industry is going to need to get on board with, likely sooner than later.
Interesting. Well, thanks for coming on the show. This has been great. I appreciate your time.
Yeah. Thanks for having me.
I'd like to thank Brian for joining me on this episode of BSA by Design. You can connect with him on LinkedIn. If you want to learn more about BSA, we encourage you to visit our website at bsadesign.com. There's a link in the show notes to contact us for more information. Additionally, I've included a link to a few of the projects Brian discussed if you'd like to learn more about those projects. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. And be sure to check out BSA on social media, including LinkedIn and YouTube. That's going to do it for this episode. Join us again next time on BSA by Design.